Welcome. As Joe said, I'm with the University of Chicago, and I'm going to be talking to you about some tools that we've developed over the years for helping researchers manage their data. First, just a public service announcement in case we get interrupted. I have no control over some of our attendees. I think it's useful just for those that may not be familiar with what we do at Globus at the University of Chicago. Just to give you a little bit of background to level set. So Globus is a service at the University of Chicago. We've developed it going back now over 20 years to its early days as a toolkit, but we now run it as a service for the research community. And we're trying to build this to support all kinds of data-driven science, which nowadays is pretty much any type of science, and do so in a sustainable manner. So to that end, we do have funding from a number of sort of the usual suspects, and we're very grateful to them for continuing to fund our development. But we also have a sustainability model that depends in large part on the generosity of institutions who pay a subscription to use parts of the service. NCAR and other research groups are part of that and have been for a long time. So thank you to those folks as well. So just at a high level, what the Globus service does, at its core, there's a reliable transfer service. So you can fire off requests to move data between two different systems, or endpoints as we call them. And Globus just kind of takes care of that, so you don't have to sort of babysit things. It also makes it very easy to share data with your collaborators that don't have local accounts or direct access to some of these systems. So you can grant permissions to an external, to someone at another institution to look at your data, and then they can come along and transfer it to their system and do downstream analysis and so on. And increasingly, a lot of groups are using some of these services to build their own solutions, science gateways, data portals, and so on, that allow folks to come along and discover data and do interesting things with it. And that's where I'm going to focus most of today's discussion, because a lot of these capabilities are accessible just via your web browser. There's a command line interface, but it's the REST APIs, the interfaces that underpin all of that I believe are sort of the most interesting and necessary to automate things at scale. A couple of examples that may be relevant to you, this audience. The NCAR Research Data Archive is actually one of our very earliest adopters of some of these platform services. So they make it really easy to pull down some of the very large data sets, reference data sets, using Globus, as well as other mechanisms, of course. But we really are seeing, this deluge of data coming from instruments primarily, and you can manage experiments at some small scale by pointing and clicking and scripting things. But at some level, you really need larger scale automation. And what we see as sort of a common theme or a flow is something like this. So you have an instrument that's generating data, in some cases running almost 24/7. What you'd like to do is be able to pull that data off the instrument automatically, move it somewhere, perhaps stage it, do some cleanup on it, ingest it into some other system for analysis, and then perhaps push out results for your collaborators or for others to use. So being able to do this is critical, not only to move things along quickly, but really because these shared instruments are very expensive resources. It takes a lot to get people to schedule time on them. They have a narrow window within which to use the instrument. Then the data has to come off there pretty quickly to allow the next group to go and do their experiment. And so it's particularly important that you don't lose any of that data. Sometimes you can't recreate these experiments very easily or at all. So being able to do this in a robust way at scale is really, really becoming quite critical to a lot of these facilities. And one example that I'm going to talk about today is the advanced photon source at Argonne National Lab, where they do lots of 2D and 3D imaging experiments on their various beamlines. And you can see there, the amount of data that was being generated about 5 years ago, and we're now expecting that to have grown by 2 or 3 orders of magnitude, especially with some recent upgrades to the beamlines themselves. So with all this data coming off these instruments and all these requirements to make it generally available, one of the things that the team at Argonne has done is they built a portal called Petrol Data. So I'm going to quickly pop over and show you what this looks like. Of course, there's no such thing as a live demo that doesn't go wrong, so I'm hoping everything works here. But this is a system actually that's been in production use for quite some time now. So you can see here we have a number of different experiments or collaborations that are using the APS for their data, and then they're pushing their data out to others. In some cases, you can see some of these repositories are marked as private. I'm going to pick on this ExaLearn project, which is a machine learning applied to exascale computing. And this is a collection of data sets from various projects underneath this ExaLearn umbrella. So, for example, if I'm working on tomography using GANs, I may be interested in this data set here. And you can see the data published here. On the left, we have some search facets, as we call them, that you can use to progressively sort of narrow down your focus and find the exact data that you're looking for. So this is really a small data set. There's 16 items in here, and there's only one facet, the number of projections. So I can sort of reduce that and filter the results, and that'll narrow them down to 4. And then when I go and say, okay, I think I'm interested in this one here, I see a preview of that image. There's, in some cases, there can be multiple previews, so I can get an idea of what that looks like. I can get additional metadata on that particular data set. And then in some cases, in this case, it's a single file, so I can click download via HTTPS, and it'll fire off a download through my browser. But in some cases, the data, in many cases, actually, the data are much, much bigger. So what I really want to do is use a more reliable service like the Globus Transfer Service to move it to my system. And you can see here this transfer sync button is disabled right now. That's because I haven't logged in to Globus yet. So this Petrol Data portal uses the Globus auth system, which I'll talk about next, as a way to authenticate. So in this case, I'm going to log in with my University of Chicago credentials. Let me make that a little bigger so you can see it. So it redirects me to my campus login page. I log in, and then I get redirected back to the system. Oops. And like I said, there's no demo that goes without a hitch here. So let me just go back to that page. I think that was because I was playing around with it earlier. So let me pick that data set. Oh, okay. Well, so looks like I can't really show you that right now. But well, what should happen is I should be getting a link to move that data down to my system via Globus. And so the main point here is that you can build these data portals that have pretty sophisticated search capabilities, and different mechanisms for making data accessible to the various collaborators by using some of the platform services that we expose. So you might be asking, okay, that looks interesting. How do I get one of those? Well, what we like to point folks at is this concept of the modern research data portal. So it's sort of a design pattern for building science gateways and data portals. And if I break it down, there's really 4 parts that go into this overall solution. Underpinning all of this is some core infrastructure in the form of a science DMZ and some data transfer nodes for moving data efficiently. And then we overlay some of these platform services and use some software called Globus Connect to actually talk to the storage systems where the data live. And for those that have some portals in place, you might be wondering, well, what's wrong with my LRDP, my legacy research data portal? If nothing else, if you've been doing something the same way for the last 10 years, you're probably doing it wrong. That's courtesy of Charles Kettering, prolific inventor from the early 1900s. And the legacy portal architecture looks something like this. You have your file system, your data store, and your portal, and all of that sitting behind an enterprise firewall. And that doesn't really create an optimal path for data to flow. So the ESNet team out at Berkeley Lab were ones that sort of came up with this concept of creating this science DMZ and moving your data transfer nodes outside of the firewall, while still keeping the portal server itself behind it, because there's usually some business logic and flows that you want to protect a little more tightly, but you can still have a secure data path through the science DMZ and ensure that data are moving more easily. So for those that are interested, as I said, the ESNet team have done a spectacular job of defining and promoting this type of architecture, and it's very widely deployed, as well as specifying what constitutes a good data transfer node and so on. So if you go to fasterdata.es.net, you'll see a wealth of very useful information. So once you have that in place, you want to connect your storage systems into this broader solution. Globus has a piece of software called Globus Connect that you deploy on the storage system or on a data transfer node that talks to that storage system. And we currently support a number of different storage systems, both traditional POSIX style, as well as many cloud object stores. So you have that infrastructure in place, and now you're looking to build a solution like the petrol data portal that I showed you earlier. And what really goes into that are four different things. We believe, underpinning all of this is a authentication authorization platform, which we call Globus Auth. And then you want to build the data description and discovery services that allow you to do that faceted search that I showed you, and then have the ability to selectively pull data and share data with others, and then potentially downstream orchestrate some of that in an even more automated way and incorporate computing and so on. So I'll talk about each of these in turn and share some of the services that are in place to make this possible. So at the base of everything is this identity and access management service, which we call Globus Auth. And what it does is it's not actually an identity provider. So it's not creating usernames and passwords or things like that. We rely on the various institutions to obviously control and manage those identities. But then with Globus Auth, we provide nice mechanisms for brokering communication, sort of security, but amongst these different federated systems, as well as amongst different services and applications and so on. And all of this is using standard OAuth 2 and OpenID Connect. So if you're familiar with those services, you should sort of understand what I'm saying. If you're not, suffice to say that this is really where the research world is moving to, sort of more modern web mechanisms for authentication and access control. So we sort of went there many years ago and made an investment, and we've been really happy with what we've seen since then in terms of adoption. We've seen a number of different use cases where Auth is being applied. There's some simple ones like using Globus Auth as just a way to sort of outsource the authentication authorization. So DataSite is a good example of that. If you go to the profiles service that DataSite has, where you generate DOIs and so on, you'll see it actually prompts you to log in via Globus. So you select your institution, you log in. There are other cases where login is sort of the gateway to compute service, like the Sanger, Wellcome Sanger Trust in the UK has a genomics imputation service that they use, and they use Globus to authenticate as well as to move the data and share the results with their collaborators. So lots of different cases where we see that. Uh, and it all starts with registering an application. So the first thing you would do as a developer is go to developers.globus.org to register your app. So here I'm showing my data portal, an application that I've registered. I define what are called scopes in OAuth 2 land. So that's really a way to implement a least privileges security approach. So you grant, you request a certain set of attributes that you would like the application to be able to access on the user's behalf, and that's what will be made available to your application. So at the end of that, you get a client ID and a secret, and those are the two pieces of information that you then use to talk to the Globus Auth service, which in turn can broker interactions with other services to get access tokens and so on. So one of the first pieces I showed you in Petrol data in that portal was the ability to search. So that search capability is made possible by the Globus search service. So what that is a service that allows you to create essentially a large searchable index, push metadata out to the search service, and very importantly, it's metadata that you define. So the search service is schema agnostic. It really develops the schema dynamically as you provide it with the various attributes that define your data set. And then it allows you to do both some simple queries using just a URL with query parameters, or to do more complex search queries by sending a more comprehensive document and posting that to a different URL. So the way the flow works is you can ingest data by posting to this URL here. And here I'm showing a very simple ingest document. So it's just providing one metadata item here. And the one thing I want to focus on is this visible to parameter here in the middle. And it says visible to public. So this is going to be a piece of metadata that is available to everyone that logs into that portal. And this is really an important thing that I want to highlight, which is the ability to provide very fine-grained visibility and control on the actual metadata themselves, in addition to the data. So we typically think of restricting or controlling access to the data sets, but it's equally important to control access to the metadata that describe those data sets, so that only certain people can see certain metadata attributes when they're searching and so on. So perhaps you want your administrator to see specific information about usage or whatever other parameters, and you want other folks to be able to see perhaps just the scientific attributes of the data. So here's another example where I'm actually limiting the visibility to a specific Globus Auth identity. So that could be a single user, but more typically it's a Globus group, so that I can share with, I can provide that metadata, make it visible to anybody who's a member of that group. Or if I'm actually doing this in a more automated fashion, and I expect other applications to access this index, I can actually restrict visibility to a specific client application or a set of applications. So again, these are all things that you define as a user. There's no preconceived notion of access control. It's really up to you to implement the policies that you want. So once you have the data ingested, then you can do, as I said, simple queries. So I could send a request to the index search and then give it a query parameter. So in this case, I'm asking for all data sets of type HDF5. So then I'll get back some search results. And again, you'll see this is all JSON, so it's really easy to parse with pretty much any language. Python was highlighted earlier today, and I know a lot of people use that. So that's pretty straightforward to do. If you wanted to do something more complex, you actually have to post a request with a search document. So here is again a very simple example. that includes some filters. So I am requesting data where the publication date is from anywhere, anytime up until the end of last year. And then I'm also requesting certain facets on which I can search. So clearly one would be publication date. And there typically would be a list here that of search facets that you want to get back to populate your page, your search page, so that users can then filter their data and so on. So once you've got the data, I sort of showed you the transfer, who had the little hiccup there, but the way that you set up the transfer is, as I said, it's most common, instead of making this available to individual users, is you create groups, and then what you do is request that users become members of that group. So then your application at runtime can check, it can query the Globus group service, get back a list of memberships. So it'll access the groups, my groups endpoint. So that'll tell it which groups I'm a member of. If I'm a member of the group that is allowed to access this data, then I can grant access, and I can fire off a transfer request and move the data. So that is the sort of the core functionality that I showed you. What we have been working on, this is sort of our current focus for development, is taking this to the next level of automation. So we're working on a service called Globus Automate, and you can think of this as I hate to use the word a workflow, but it's essentially a data flow with the ability to have human in the loop for approvals. So for instance, we have one use case where data coming off a beamline, before you run the entire experiment, you get a handful of images back. They get staged to a location, there's some pre-processing done, and then a human looks at them and ensures that they're getting the right quality, making sure that the beamline is properly focused and so on. And then once that's all good, then they'll sort of press the go button, which will then run the rest of the experiment and generate a whole bunch of data. That whole flow can be automated through the Globus Automate service. So this is a little bit of an eye chart, but I want to focus on two things here. So there are events. So events occurring on a system. So the beamline just generated a new set of files for this sample. That would be an event. Or, my compute job just generated a set of results. That might be another event. So you can register these events, and these events then trigger actions. So the actions can be as simple as fire off a transfer via the Globus service. So move this data from here to here, perhaps create a copy of it in an archival system or whatever the case may be. And increasingly, it's actions like run a compute job somewhere. So I'll talk about where we're going with that next. But the way we've designed this is as an open system where anyone can come along and define their own, register their own events, and most importantly, create their own action providers, as we call them. So if you want to enact an action on some specific device, on some specific computer or some piece of code or an application, you can define that. There's an API that allows you to plug that into the system and register that action provider. So then you can include that in your automate flows and just have them run. So this is, as I said, something that is in late stages of development. It's actually in use in production on a number of these APS beamlines. And we are going to be making it more generally available in the next couple of months. So if that's of interest, by all means, please follow up with me offline. The other piece that is being developed is the ability to essentially use clusters or supercomputers or cloud computing systems into HPC function serving systems. And so if you're familiar with things like Lambdas on AWS or compute functions as a service on Google Cloud Platform, this is the same idea, except that you can deploy this kind of infrastructure very easily on your own compute systems, be they an on-prem cluster or what have you. So you deploy the system that we call FuncX. You deploy a FuncX endpoint onto your compute system, and then the Globus FuncX service will route these compute requests to the endpoints, and they run inside of containers. So those can be Singularity. That can also be other things like Docker and so on. And it's all secured, again, by Globus Auth that I talked about earlier. So that's just a preview of what's coming. This is very much sort of working in the labs and in a few specific use cases, but will be more available later. So I'll leave it there. I think I've got a couple of minutes left maybe. So here are some links to get you started. The mrdp.globus.org is a good starting point for examples. And then all the documentation on the services I talked about is at this URL here.